this is what I want to make today. And this is just multiple linear gradients stacked on top of each other. And a linear gradient is just a smooth transition from one color to another. So let's start with working on that. And before we write the code for transitioning from one color to another, let's write the code for transitioning between one number and another. So the starting number, call it A, and number, call it B, and then some value for how far we are between those two numbers. And that number will go from 0 to 1. I'll call that P for percentage. So at P equals 0, this should return A. At P equals 1, it should return B. And then we should get some intermediate value for P's between 0 and 1. Which is exactly what this does. So if P equals 0, this term goes away, and we just get A. If P equals 1, then this negative A cancels this A, and we just get B. And then we just linearly interpolate between those two values. So it's pretty easy to interpolate between two colors instead of two numbers. Let me go ahead and define a type to represent a color. Just values for our G and B. And then let's extend this. Cool. So we just treat the R, G, and B values as numbers and interpolate between those like we would interpolate between regular numbers. And we do that for each one of these, then we'll interpolate between these two colors, color A and color B. So now all we have to do if we want to smoothly change between two colors throughout this picture is produce a value, this P value, as we go down the screen. So let's go down the screen one pixel at a time. The P value is going to be Y over height minus 1 because we never actually get to the full height. So P will go between 0 and 1. And then we're just going to interpolate between these two colors. In this case, we're interpolating between red and blue. We'll set the fill style to that color. So just mapping this color to a string that this library understands. And then draw a rectangle that has height 1. So it's just filling up that line with that color. And then repeat as we go down the screen. So again, we should be smoothly transitioning between red and blue as we go down the screen. Awesome. And just to make sure this works, let's do something else. Let's maybe sprinkle in some green. Nice. Or we can make this all green. Awesome. So that's a single linear gradient. I mentioned that to create this picture, this is actually multiple linear gradients stacked on top of each other. If you want to make something like a sunset or more complicated things like that, one linear gradient like this one on the right isn't enough. You actually need multiple stacked on top of each other. But that's not really any harder to do. It's just what we've been doing, but define multiple ones instead of one. So maybe the hardest part is just the data structure for how you define those different gradients. So we have different gradients starting at different points on the screen and call these stops. So we have an array of these things, which are exactly this. It's where do they start on the screen and what color do we want to get to when we reach that point on the screen. So I'm actually going to call this P to keep it in sync with this parameter on our interpolate functions. So this would define going from green at the top of the screen to yellow in the middle and then to blue at the bottom. And now we just need a function that can map a global p-value to figure out which gradient we're within. And then within that gradient, interpolate to the relevant color. So for this, we just pass in a p-value because the colors are defined here. And this is going to return a color. And we're going to go through all the different stops that we've defined and find which one we fall within. So loop through all the stops, get two adjacent ones, see if this p-value that we passed in falls between those two stops. If it does, those are the two, that's the linear gradient that we're within at this point. Then get this local p. So an example of this is if the p-value we pass in here is 0.75, we're within this linear gradient going between yellow and blue. Within this gradient, since we're 0.75, we're actually halfway between these two colors. So the local P here should be 0.5, even though the global P is 0.75. And the way you do that is you just see how far are we from the start color, and then what's the total range between those two. And then now that we have the two colors we're interpolating between and the local p-value, we can just call that interpolate color function that we defined earlier. And all that we have to do now is change this to that new function that we just defined. So now we should have two linear gradients stacked on top of each other. We're going from green to yellow and then yellow to blue. Awesome. You can already see that we can do a lot more complex stuff now that we're mixing linear gradients on top of each other. So I'll show you what I did to get this sunset looking one. I had this picture of a sunset that I took, and I just used the color picker tool and grabbed multiple points in the sky here. I'm going to add each of these to my palette. And so we go from like this dark blue to this lighter blue. So let's call that one gradient. And then we go from this lighter blue to this orange. It's another gradient. And then we go from this orange to this brighter orange. And then at the bottom, we go from that brighter orange to a red. So I grabbed all those values. I'm just going to say those are all linear gradients on top of each other. I'm going to replace these example stops with those ones. So again, these colors I just got from that color picker tool. And then that's how we produce that sunset. You can do a lot of little tricks to change things around. So you can see that like the blue is only occupying the top bit of the screen. You could shift that down. Let's see. Yep, so now the blue is filling up more of the screen. That's nice. Another thing you can do is you can actually manipulate where these p-values are. And what I mean by that is, so the p that we're passing in here is like the global p. It's the percent that we are down the screen. But before getting the color, we could map that to a slightly different value. We could do something like this. We raise it to some power. So if we square it, then because the number is between 0 and 1, squaring a number between 0 and 1 just makes it smaller. If you take the square of 1/2, it gives you 1/4. So this kind of pushes things down the screen for us. So just compare what this looks like now, should shift everything down the screen, which sometimes can give you a more realistic looking sunset. So that's it. We're at 56 lines of code. Some very basic math here for interpolating between two numbers, extending it to interpolate between two colors, and then just stacking multiple of those linear gradients on top of each other, and you can create realistic looking sunsets. I got all the code in the GitHub. Check it out, play around with it, and I'll see you next time.